last lecture we started with the definition of series. How this series came, first of all, we saw if summation minus 1 raised to n liya, then I'm writing 1 minus 1. If I'm combining first two number, then next two number, like this, everybody is 0 0 0, then final answer is 0. But if somebody says that I don't want to take the first number, I'm taking second, third, fourth, fifth, and like that. I'm combining two people, and again this is zero, this is zero. So I'll be having one. So why this ambiguity is there? That is one. Once if I'm going with this, then I'm getting zero. If I'm so, what is wrong with this series? Correct. See, this is what we want to understand. So that's why the series. So we want to define a rigorous way to avoid this ambiguity. Correct. So and same you see 1 by 3 is equal to 0.3333, so I can write this as 3 by 10 plus 3 by 10 square plus 3 by 10 cube, so on. Correct. That means what? This is summation n equal to 1 to infinity 3 upon 10 raised to n, that is giving me 1 by 3. So this is a series which converges to 1 by 3. In the previous case we saw we are having one series which converges to 0 and 1, and here this is a series which converges to only one number. So my question is that whether can we say a series converges to a single number, a real number, correct? And that will be called as convergence of series. So let us define what is series first. Given a sequence En of real number, a formal sum of the form this n equal to 1 to infinity of En, that is e1, e2, e3, and so on. And this is symbol. If I don't write n here, then it is that is n equal to 1 to infinity. Summation En, that is called infinite series. And for any n belongs to natural number, the finite sum. If I take only n terms of this, that is I'm denoting it by Sn, that is e1 plus e2 plus e3 up to en, then this is called nth partial sum of the series. Correct. This is called nth partial sum. This is your series, infinite series. This is Sn is nth partial sum, and Sn को denote करेंगे तो यहाँ पे n लिखेंगे. That means it is up to nth term only. सो डू यू सी हम लोग का स्टार्टिंग में दिस वॉज अ सीरीज, इसको मैंने एक सीक्वेंस में बनाया. दिस एस एन इज अ सीक्वेंस विच डिपेंड्स ऑन योर एन. करेक्ट. सो दिस इज अ सीक्वेंस. नाउ लेट अस डिफाइन व्हाट इज द कन्वर्जेंस ऑफ सीरीज. And I gave an example. If your en equal to n, then what will be my sn? So s1 क्या रहेगा? फर्स्ट टर्म का एडिशन. s2 क्या रहेगा? दो टर्म का एडिशन. s3 क्या रहेगा? तीन टर्म का एडिशन. So what will be my sn? It will be 1 plus 2 plus n. So my question is that whether yeah, so no, let us not go to that question. Let me first define that. What is convergence and divergence of a series? Let en be a sequence of real number, and summation of en be a associated series, and let Sn be a sequence of partial sums of the series. Correct. Then this series is said to be convergent series if Sn is convergent sequence. Sn the associated sequence of partial sum. If this sequence is convergent, then I'll say that series, my original series, is convergent. That means if limit n tending to infinity of Sn, that is equal to say a, then I will say that summation n equal to 1 to infinity of en, that is equal to a. दैट इज एज सिंपल एज दैट. सो हम लोग ने सीरीज का डेफिनेशन रिड्यूस कर दिया सीक्वेंस के डेफिनेशन से. सो मतलब मुझे चेक करना है वेदर दिस सीरीज इज कन्वर्जेंट. आई जस्ट हैव टू चेक दिस सीक्वेंस एस एन, दिस इज कन्वर्जेंट, दैट्स इट. करेक्ट. ओके, लेट अस सी. If and when this is divergent, when sequence of partial sum, that is Sn is divergent sequence, then we say that series is also divergent series. Correct. Then the same example जो हम लोगों ने लिया था, summation n equal to 1 to infinity n, what is s1 1, s2 1 plus 2, and what is sn here? This is 1 plus 2 plus 3 up to n. So what will be my Sn? Do you see this is sum of first natural number, so I can calculate it, that is n into n plus 1 by 2. Now my question is that whether this Sn is convergent or divergent. Correct. So you just have to take limit n tending to infinity of Sn. That means limit n tending to infinity. This is n plus 1 by 2. So you see where n goes to infinity and n is in the numerator. So this is infinity. that means your Sn is a divergent sequence. So this Sn is a divergent sequence. What do you mean by that? That means this series is divergent. To check whether this is convergent, I went on to Sn. Now if this Sn is convergent, then my series is convergent. If Sn is divergent, then my series is divergent. Right? Let us see one more example. Here we got that this summation n is divergent. Okay, let us see the next one. Suppose I am having this series summation 1 by 2 raised to n. That means what? If s1 s what is s1? This is 1 by 2. What is s2? This is 1 by 2 plus 1 by 2 square and so on. What is sn? 1 by 2. It will be up to n term. Correct? And you know something. You know a geometric progression. Geometric progression. Later on we'll see. Later on we'll see how do you, yes, GP, correct. Later on we'll see how do you get this formula, but let us just use it here. So I need 1 by 2, 1 by 2 square. I need first term as 1, so can I take 1 by 2 outside? So if I take 1 by 2 outside, I'll be having of the same form 1 by 2, 1 upon 2 raised to n minus 1. Correct? And what is the common ratio for this series? 1 by 2 is my common ratio. So what is the formula? 1 minus x raised to n upon 1 minus x. So it will be 1 by 2 as it is. 1 minus 1 by x raised to n. So 1 by 2 raised to n, and this is. So this is again 1 by 2. This is cancelled. So I'll be having 1 minus 1 by 2 raised to. So this is my Sn. Now can you tell me whether Sn is convergent or divergent? Sn is this 1 minus 1 by 2 raised to n. If you see 1 is a constant, so ये तो 1 ठीक है. This is 1 by 2 raised to n, and we know sequence में हम लोग ने कुछ तो पढ़ा था ये. If your B is lying between standard sequence, if you remember, sequence chapter, standard sequence में if your B is lying between 0 to 1, then B raised to n goes to 0. Perfect. So look at this guy. If you take limit, this is okay, but this is 1 upon 2 raised to n. That means B is your 1 by 2. B is lying between 0 to n, and that goes to n. That goes to B raised to n. So that goes to 0. So answer is 1. That means this Sn is converging to 1. So what is my conclusion? My conclusion is this series is convergent. And where that converge to, this converge to 1. Correct? Do you agree? Yeah. So let us see why the see, look at the solution. I just use this in terms of sequence. Sequence का यही property use किया. Can I take any B which is between 0 to 1? And yes, obviously yes. So if I am having, so let us do in general something. I want to write a theorem, that is summation n equal to 1 to infinity x raised to n minus 1. That is geometric progression, GP. So I'm going to talk about this guy. This is convergent if x is between 0 to n. Even if and only if लिखा तभी भी चलेगा. Correct? This guy is convergent. This series is convergent if and only if your x is lying between 0 to 1, then only it is convergent, otherwise not. Even it is 0 लिया तो convergent है, तो that is not an issue. तो मैं just exclude कर रहा हूँ. Correct? If you include 0, then also it is okay. Okay, so you can take two cases. Case 1, suppose x equal to 0, then this is a 0 series, so that is convergent. So I'll be taking the second one. So what is s1? That is 1. What is s2? That is 1 plus x. S3, 1 plus x square. And what is sn? 1 plus x plus up to x raised to n minus 1. Now if I want to calculate value of sn, so let us multiply by x in the above equation. If I multiply by x, I will be having x into Sn, that is equal to this term. This will be x, this will be x square. So I'll be writing, just keeping some space, I'll be writing x square. This guy will be x raised to n. So if you see, if I subtract these two, this is cancelled, this is cancelled, everything cancelled. So here in the left hand side I'll be having Sn minus x into Sn, and on the right hand side I'll be having 1, and here since I'm subtracting, so it will be 1 minus x raised to n. So what is my Sn ka formula? This is 1 minus, this is how what I told you कि हम लोग later on we'll see how to derive this formula. So this is how we got the formula, the value of Sn. Correct. Now what is the next question? To check whether this series is convergent, you have to check about whether this Sn is convergent or not. So let us see. What is Sn? I just separated this 1 minus x raised to n. I separated 1 upon 1 minus n. So there is no term of n. So ये कोई problem ही नहीं है मेरे लिए. So I just have to see this guy. That is limit of Sn. This is equal to 1 upon this. And in the denominator also there is no term of n. So I'll forget about this. And this is. And when do you say this guy goes to 0? And we know that your standard sequence b raised to n is 0 if b is 0 to 1. And in my question, it is given if my x is between 0 to 1, then I'll be having this term as 0. So मेरा Sn क्या रहेगा? This will converge to this 1 upon 1 minus x. That means limit n tending to infinity Sn, that will be 1 upon 1 minus x, and that's it. So my summation x raised to n minus 1 is equal to 1 upon 1 minus x only if x is between 0 to 1, correct? Otherwise not. If you take x any greater than one value, or if we take 1 also, then it is divergent sequence. So you need to make sure that. Correct? Yeah. So by using that, can I say about this? Where does this guy converge? 4 by 5 raised to n minus 1 रखा तो ये क्या आएगा? It will converge to 1 upon 1 minus x. That is, see, this is 4 by 5, that is between 0 to 1. So I can directly write 1 upon 4 minus. This is 10 by 11. Yeah, this is again less than 1. Correct. So answer will be 1 upon 1 minus 10 by 11. 5 by 27 लिया तो this will converge to 1 upon 5 minus 10. And you can prove. Correct. So geometric progression हम लोग ने एक theorem proof कर लिया. Whenever you see something like this, so ये converge कब होएगा? When your x is between 0 to 1. So you need to remember that. Okay. Let us see some more example today, and then we'll see some properties or some tricks to solve. But before that, let us do some example. Uh, Summation 1 upon n into n plus 1. Check whether this series is convergent or not. Can you do that? How will you start? You start with S1, S2. Look at what is Sn and tell me. What is S1? It will be 1 upon 1 into 2. What is S2? 1 upon 1 into 2 plus 1 upon 2 into 3, correct? Sum of two terms, E1 plus E2. And what is Sn? It will be 1 upon 1 into 2 plus 1 upon 2 into 3 plus so on. It will be 1 upon n into n plus 1. Do you agree? This is your Sn. Can somebody tell me how to solve this Sn? Whether this is convergent or not? ऐसे क्वेश्चन हम लोग ने किए हैं, अगर तुम लोग को थोड़ा सा याद होगा तो. Can you tell me whether this Sn is convergent or divergent? I just want somebody to answer, maybe, if someone can. How to check whether this is convergent or divergent? This is a sequence, and ऐसे sequence हम लोग ने देखे हैं कैसे convergent proof करने का. Yes, tell me. Yeah. See, there is always a trick of this. हाँ बोलो बोलो. Yes, yes, tell me. Okay, no issue. Yeah, there is always a trick. If you are having consecutive terms in the denominator, that is 1 into 2, 2 into 3, and like this. So I can write this, I'll write here 1 into say n into n plus 1. I can write this as 1 upon n minus 1 upon n plus 1. Just check whether can I do that. This is hint for you. Can I do that? That is, if I'm having consecutive terms, that is n plus 1, 1 2 2 3 3 4 like this, then this is the trick. I can write this guy as 1 upon n minus 1 upon. Let us do cross multiply karo, check karo whether this is same. Correct. N plus 1 minus n and n got cancelled. I'll be having n into n plus 1 in the denominator. Perfect. So can I do the same thing with every, for each of the terms? Let us see. That means the first term I'll be having, this is 1 upon 1 minus 1 upon 2. Next term I'll be having 1 upon 2 minus 1 upon 3, and so on. I'll be having 1 upon n minus 1 upon n plus 1. Do you agree? I'll be having this, correct? And since it is addition, do you see everything is getting cancelled by someone? The second term of this guy is cancelled with this, and this will be cancelled with this. I'll be remaining, even this guy will be cancelled with somebody. I'll be remaining with this first and last. Do you agree? So I'll be having just 1 minus 1 upon n plus 1, and this is called actually telescopic series. Telescope, that is, I'm seeing from here, I'm getting the last value directly. This is a telescopic series. I'll talk about it later. Let us just see. Correct. So what is my Sn now? This is 1 minus 1 upon n plus 1. So whether Sn is convergent or divergent, that is the next question. That means you need to see this. What is Sn? That is 1 minus 1 upon n plus 1. You need to take limit and tending to infinity of Sn and see what is that. This will be 1 minus limit and tending to infinity of 1 upon n plus 1. And you know what about this? This goes to 0, so I'll be having 1. That means your Sn converges to 1. So what is your conclusion? Your conclusion is summation of n into n plus 1 converges to 1. Oh, I'll share the screen. What is my conclusion? My conclusion is, since my Sn is convergent, so what is my conclusion? My conclusion is this series is convergent. That is, this series summation 1 upon n into n plus 1, this converges to 1. Means proved. Or no, it was not a proof. Let me ask you, let me just now define what is telescopic series. Telescoping series. Telescoping series. Okay, let me just define. Let En and Bn be two sequence of real number sequences such that say En equal to this Bn plus 1 minus Bn, correct, where n is greater than equal to 1. So note that what will be my Sn here, that is what is my what is my E1 here. E1 is my B2 minus B1. What is E2? It will be B3 minus no, actually I'll just yeah, let us see what is S. hmm. Say Sn B, and I want to talk about this. I want to talk about summation of En. So what is Sn? Sn, for Sn I need S1, S2. Sn is what? E1. S2 is what? E1 plus E2. So what is my E1? E1 is B2 minus B1. And what is E1 plus E2? It will be B2 minus B1 plus, it will be, what is E2? E2 is B3. It is minus B2, correct? And you see somebody is getting cancelled here. B2 getting cancelled. I am having just B3 minus B1 here, correct? So similarly, I need to talk about Sn. It will be E1 plus E2 plus up to En. That is what? This is B2 minus B1 plus this is B3 minus B2 plus this is last term will be Bn plus 1 minus Bn. You see everybody will get cancelled. I'll be having just first and last term. That is, this is cancelled, this is cancelled, this everybody. So I'll be having this first and last term. That is Bn plus 1 minus B1. So that's why this is called telescopic, correct? So what will you say? I'll say that this summation of En converges if and only if limit of Bn exists. Limit of Bn exists. Correct. You see, because if limit of Bn exists, then this will exist. Yeah. So summation of En, this series is convergent if this guy, this Bn exists. That's it. Correct. Let us see one more example. Most famous example, that is summation n upon n raised to 4 plus n square plus 1. So you need to check whether this series is convergent or not. If you have done something in your polynomials, then you'll see this is a special series, special polynomial. That is, this can be written as like this. That is En. I'll talk about En. This En, that is n upon n raised to 4 plus n square plus 1. This guy can be written like this. This is a special one, that is n square plus 1 the whole square minus n square. It is actually like this. Yeah. So what do you mean by this? This is 1 upon, this is a square minus b square, so n square plus 1 minus n square, and n square plus 1 plus it will be just n plus n. Correct. So what do you mean by that? Now by using partial fraction, can I write this of this form, that is n square minus n plus 1 and something uh, n square plus n plus 1. By using partial fraction, you can easily see, and you'll see that this is just 1 by 2. Both the guys 1 by 2. Here this is minus, that's it. And you'll see again uh, this is of the form En equal to Bn and Bn plus 1, same as the previous one which we defined. That is again, this is a telescopic series. That is, note that the sum in bracket is a telescopic series. And what is Bn for me? With Bn equal to this, that is 1 upon 2 1 upon n square minus n plus 1. This is my Bn. Hence your Sn is, hence that is summation of En converges if this Bn convergent, and you already know that this Bn goes to 0, where Bn goes to 0. So your this series is convergent. That was easy to do. Correct? Yeah. Okay. So we stop for today now. Thank you so much.